In this video, we are going to be tackling questions on reacting masses. Now, in this question, the format is always the same. You are given a balanced chemical equation. You will be given the mass of one substance. In this case, you're given the mass of iron, and you need to work out, the goal is to work out the mass of one of the other substances, usually the product, in this case, iron oxide. So, how can we use the mass of one substance to find the mass of the other when given the balanced chemical equation? So, the first step is to bug our question. We need to first box the command word, which is to calculate. In this case, we're calculating the mass of iron oxide produced when 45 grams of iron reacts with oxygen in excess. So I've underlined the important value and the substance there as well. Next, we need to put this information underneath our equation to make it really easy for us to follow. So we're summarizing what we're told in the question in a way that's easy to follow. So we're calculating the mass of iron oxide. So iron oxide is unknown. This is our goal. We are told there are 45 grams of iron. Now, the next step for me is just to write down the mole ratio of the two substances that we are interested in, and the mole ratio is 4:2. I don't need to worry about the oxygen, and I don't need to think about these numbers anymore because I've got them written down here. The next step is, because I know the mass of iron, I can use this mass to work out the number of moles of iron. So my new goal now is to work out the number of moles of iron. So in order to do that, I need to figure out how many moles I have using the mass, which is 45 grams, and the relative atomic mass of iron, which I can find in my periodic table, and I know that iron has an atomic mass of 56. So I'm going to use my formula, number of moles equals mass over AR. I know that number of moles equals 45 divided by 56, and putting that into my calculator, 45 divided by 56 gives me N as 0.80357 something moles. I'm going to keep that to 4 decimal places for now because I'll be needing this number later on. Right, now that I know the number of moles of iron, I can use my mole ratio to figure out how many moles of iron oxide I will produce. So just to reiterate, what we've done so far is we've converted the grams, the mass of iron we have in grams, into moles. The reason I've done that is because if I know how many moles of iron I have, I know, because of the mole ratio, I'll have half as many moles of iron oxide because the ratio is 4:2. So we're going from 4:2, which means I'm going from 0.8036 to half of that, which is 0.4018 roughly. Now I can use this, which is the number of moles of iron oxide, to convert into grams using the same formula here. So this time I'm looking at Fe2O3, so I'm going to write that into my margin. I know my number of moles is 0.4018 moles. I know my mass is what I'm trying to figure out, and I know that the relative formula mass of iron oxide is going to be, I've got two atoms of iron, whose relative atomic mass is 56, and I've got 3 atoms of oxygen, whose relative atomic mass is 16. So 2 times 56 gives me 112, and 3 times 16 gives me 48. So together, the relative formula mass of iron oxide is 160. I'm going to substitute these numbers into the formula. Number of moles equals mass over mR. 0.4018 equals m over 160. I'm going to rearrange this by multiplying both sides by 160 to give me mass equals 0.4018 multiplied by 160, and that gives me a mass of 64.2857 grams, which to 3 significant figures is 64.3 grams. That is my final answer. I have used the mass of iron to find out the moles of iron. I've used the mole ratio to find out how many moles of iron oxide I have, and then I've converted the number of moles of iron oxide into grams, which in this case is 64.3.